Assalamualaikum and good day everyone. Today we will continue our chapter 4, 4.6 shortest path problem. At the end of this video, you should be able to understand shortest path problem, find the length of the shortest path between vertices using Dijkstra algorithm, and understand and solve traveling salesman problem. So first, let's see for the wasted graph. What's meant by the wasted graph is the graph that has a number assigned to its age. So we see in the figure 4.6.1, we see that there are number assigned to its age. So this graph is called wasted graph. The problem which model using the wasted graph is the airline system, the computer network. So there are type of problem that need to solve in the shortest path is the smallest flight time, cheapest fare, fastest response time, shortest distance, and also the type of problem that need to solve a circuit which the shortest total length that visit every vertex of a complete graph. Exactly one is the traveling salesman problem. So let's see the shortest path algorithm. What is the shortest path between A to Z in the given wasted graph? Okay, let's see in the figure 4.6.2, we have the wasted graph here. So we will solve this problem by finding the length of a shortest path from A to a successive vertices until Z is reached. Okay, let's see for we need to find how we want to find it. We list all the possible paths with its length. So we have we need to find the path between A to Z. So from A to Z, so we have the A to Z through the vertex B and the vertex C. So how we want to calculate the length is by adding the number at the edges. So we have the 4 plus 3 plus 2. So we have the total length is the 9. So the path is A to B to C and to Z. So we have the length 9. So there are another path from A to Z. So we see the A to B to E and to Z. So we have the length here is 8. And we have the A, D, E, Z is the another path. So we have the length 6 and we have the also the path A, D, E, B, C, Z that have length 13. So we need to find, so this is the all the possible path with its length. So we need to find the shortest path. So we have the smallest length is the shortest path. So the shortest path here is the length 6 with the A, D, E, Z. So this is the motivation for the shortest path algorithm. So here the highlight today is the Dijkstra algorithm. In the Dijkstra algorithm, we call the starting node as the initial node, and the distance of a node y will be the distance from the initial node to it. The Dijkstra algorithm will assign some initial distance value and will try to improve them step by step. Here is the step for the Dijkstra algorithm. First, we assign to every node a distance value. We set it to the 0 for the initial node and to the infinity for the all other nodes. Second, mark all the nodes as unvisited and set initial node as current. Third, for the current node, consider all its unvisited neighbors and calculate their distance from the initial node. If the distance is less than the previous recorded distance, then override the distance. For the fourth, when we are done considering all the neighbors of the current node, mark it as the visited using the circle. A visited node will not be checked over again. Its distance recorded now is final and minimal. Set the unvisited node with the smallest distance from the initial node as the next current node and continue from the step 3. So let's see the step one by one clearly. Alright, let's see the example. We have the figure 4.6.3. The question is to use Dijkstra algorithm to find the length of a shortest path between A to Z in the given weighted graph. So we need to find a shorter path between A to Z. So that means that our initial node here is A. So the step 1 is we need to assign a distance value. We need to set the initial node as equal to 0 and the infinity for all other nodes. So we have the figure here and we set the initial node as 0 and the other as the infinity. So let's see the step 2. So we have the set initial node as the current. So we have the our current node here is A. So for the current node, we consider all the unvisited neighbor and calculate the distance. So we have the current node A here, and the current node A is adjacent to vertex B and the vertex C. So we need to calculate the distance from the initial node. So we have A here as a 0 path, as a 0, the value is 0, and we have the value of the edges A to B is 4. So we have the 4A here, and for the C we have 2A here. A here means that the 4 from A and C is 2 from A. So next, when we done considering all the distance, we need to mark the current node as with the circle, as it is as a mark that A is visited. Okay, let's see. For the step 5, for the next current node, we need to find the smallest distance from the unvisited node. So we already done with the A. So we need to see from B whether the B is or C is the current next our next current node. So current node, we have here the smallest distance. B have the distance 4 and C has the distance 2. So the C has the smallest distance. So our next current node is the vertex C. So we repeat from the step 3. We need to find the neighbor, the value for the neighbor. So we see C is adjacent to B, D, and E. So we have C here with the distance 2 from A, and if we want to find to B, C to B, so we have one value 1 here, so 2 plus 1. So we have the 2 plus 1 here, we get the 3. So the total is 3. The 3 is we know that the 3 is smallest than the previous recorded distance at the B, which is 4. So we need to when the current distance is the less than the previous distance, so we need to override the distance. So we need to override the distance. So here we have the 3AC. So since it is from the current node here is the C to B, so C already have 2A, so we need to bring it along. So we have the 3AC. So for the C to D, we have the 8 here. The value is 8. So 8 plus 2 is equal to 10. So our D is 10AC. And for the E is 12AC. So we already done with the C. So for our next current nodes, we need to find the smallest distance, whether from between the B, D, and E. So the smallest distance is B. So our next current node is the B. So we have in the iteration 4, we have the B as the current node, and we follow the step from the step 3 until the end. And for the iteration 5, we see that we have the D as the current node, and in the iteration 6, we have the E. Until the last, we have the algorithm will terminate and when the Z is circle, right? In the Z, we can see that we have the 13 ACBDE. ACBDE is the path, and 13 is the length of the path. Alright, so the final answer for the question is a shortest path from A to Z is ACBDEZ with length 13. So this is the final answer. There is this is the end. So there are another method in the Dijkstra algorithm is by using table. So let's see Dijkstra algorithm by using table. We have the same question, so we need to solve it by using table. So we have the 3 column here, and the first column is vertex. What we need to write in the vertex is we list all the vertices in the graph. Since we have the vertices A, B, C, D, E, Z, so we need to arrange it follow the alphabets. Okay, in the second column, we need initially we put all with the infinity except for the initial node is equal to 0, and the rest is the infinity. And for the pass, for the third column, we have the passes, and the pass is we have 1 2 3 4 5 6. This is 1 to 6 is the total of vertices that exist. So we have A, B, C, D, E, Z. So we have the 6 total of vertices here. So we need to write down the 6 passes here. Alright, so let's see how to do this. So let's see the first. We need to list all the vertices in graph. So we have the A, B, C, D, E, Z. So the next is the initially. So we put all with the infinity except for the initial node. So we see in the question that our initial node is A. So we put the initial node's value as 0 and the rest is the infinity. And for the past one, we need to tick the starting vertex. So the starting vertex is the A, so we need to tick A. And we update the value for the vertex that adjacent with the starting vertex. So we have A here, and we see it's adjacent to B and adjacent to C. So we have the 4 from A and 2 from A at the C. And for the rest, we stay infinity if they are not adjacent. Okay, let's see for the passes 2. In the passes 1, we find the smallest value. So we have at the C here. So the 2, so we need to tick for the smallest value from the passes 1. So we have 2A here. So we need so our current node here is the point C. So the point C here, we see that it adjacent to B, to D, and to E. So we already have the distance to. When it's go to the B, we see the 2 plus 1 is equal to 3. So we have we see that the 3 is less than from the previous recorded value for here. So we write down as the 3C since our current node here is C. So for the D, C to D, we have the 10, so we have the 10C, and for the E, we have the 12C, and Z is, since it's not adjacent, so it's as infinity. So for the third one, we find the smallest here. We see that the B is the smallest value here, so we have, and the thick one we just copy and paste for the next pass, no need to consider this again. Alright, so we see here the 3, 10, 12, so we have the 3, the smallest one, so we tick for the 3, and it is in the point B, so we need to consider to the point B. So point B is to D. We see that we have the 8B, since 8 is less than 10, so we have to overwrite it, so write 8B here. So for the E, since there are no adjacent to B, so we just copy and paste from the previous passes, so we have the 12C. Also with the Z, we have already have infinity, and for the rest, we already, and for the rest we do it with the same step. We need to find the smallest value from the passes, and this is the final answer. And from the final answer, how we want to read the path, right? The final answer is when the all the in the sixth path is tick. Alright, so how we want to write, so how we want to read the path. So from here we can see that a Z here is 13E, so we have E here, so that's mean we need to see the tick at the E, and so we have the tick D, at the E we have the tick 10D, so it means we need to move to D, and B here, and C, also the last one is A, so we need to read the path is A, C, B, D, E, Z. So here is our final answer. A shortest path from A to Z is A, C, B, D, E, Z, with the length 13. So we know that at the Z we have the tick 13E, so the length is 13. So that's all for the solution by the tables. So this is exercise 4.6 for you, and this is the exercise for the traveling salesman problem, so you need to try it out. So this is the additional exercise for you. So that's all for me. Thank you. Have a nice day.